All right, I just want to do a couple of these questions, and they're all going to be product rule, quotient rule, in which you have to apply the chain rule. I'll just show you how to do this quickly, or how you want to think of these, because eventually we will flip them upside down, backwards. By that, I mean, right now what we're doing is we have curves, so this is like a degree 8 polynomial, so I don't know, it looks something like this. What we're doing right now is we're trying to find the slope, the tangent slope. This is what derivatives are. It's just the slope at a given point. So you have f of x, and then you get f prime of x. So g of x, g prime of x, y becomes y prime. This is called the derivative, where you find the slope, or the rate of change is the word they like to use, rate of change. Now, we're going this way. Eventually, we'll be going this way. And this is the more important procedure. It's more used in real life. Now, what is this opposite thing called? This is called integration. The question will ask you to integrate a function. What that means is they will give you f prime of x, and you have to come up with f of x. An example would be this. F prime of x is 2x. So there's a function, f of x. When we took its derivative, we got 2x. Now, what is f of x? This one is simple. This one is going to be x squared. Because when you take the derivative of x squared, you get 2x. This is called the integral. The symbol for this kind of looks like this. So here we would write it as 2x, like that. And the answer to this would be x squared. Now, what does an integral mean? It means the area. Now, we're no longer concerned about the slope, rather we're concerned about the area. The slope, you need 1 point, an x value. To find the area, you need 2 different x values. Because if you only have 1 x value, you'll be finding the area of a line, which is undefined, because line only has 1 dimensions. Area is length times width, so it would not have one of the dimensions. So we need to somehow turn this line into a 2-dimensional thing, which basically means a rectangle. So we need to give it a width. What that means for us is that we need to give it 2 different x values. There will be a lower bound. This is the smaller x value. And then we also need to give it an upper bound. So a quick example here would be, here, let me show you what, but we'll be doing this eventually. To do integral, you first have to master derivation, and it becomes so much easier. Because it's the same thing, except you work backwards. Here, let me show you a quick example of an integral question. The question will be something like this. Find, we're just going to use our same thing that we did before, 2x. So 2x, and then we're going to say, let's say 0 to 2. And then anytime you have an integral, you need, this is just a notation stuff. It always comes with this integral sign, as well as d of whatever variable you're trying to integrate. In this case, our variable is x, so you need to write dx. This will always be the integral notation. You'll have the symbol and d something, which implies this is the variable that we're interested in. Because eventually, if you go down this path, there is a different topic called multivariable calculus, also very prominent in real life. So when we're doing a multivariable calculus, you'll no longer have one letter attached. You can have multiple, you can have an infinite number of letters. But the idea is the same. Like you can have something like this, 2xy, and you can take the derivative, the integral of this with respect to x, or you could do the same thing with respect to y. What does all of this mean? Let me show you an example here. So this is our question. Find the integral between 0 to 2 of this function 2x with respect to dx. For us, for the foreseeable future, it's only going to be a single variable. I will always try and make it x, but eventually you'll see in word problems concerning time, they will have t, dt. Doesn't change anything, it's just a different letter. So here, first let's do this the dumb way. A student is probably like, what are you asking me to do with these fancy symbols? I'm just going to do it the dumb way, which means first I'm going to sketch 2x. 2x means it's going to go through the origin and give me one more point for 2x. One of them is the origin. What's the other point? What's the point that goes through 2x? Y equals 2x. No? One of them is 0, 0, right? It's just a straight line.
Mm-hmm.
The other one, when x is 1, y is 2, right there. There we go. That's another point. We're going to connect them. We could connect them in the negative axis, but it's not needed here because our bound is from 0 to 2. So let's say a student is like, hey, there's my line. So I know integral means area. So what I'm going to do is I'm going to turn this into a triangle. This one, you can't really turn this into a rectangle. So 0 to 2. 0 is right here. When the x value is 2, what's the y value?
It's 4.
It's 4. So here's another point, 2, 4. The question's asking us from 0 to 2 in terms of x. So we're only concerned, and this part is very important, we're only concerned here to here on the x, which means on the y, you connect the y values. So here the y value is 0. Here the y value is 4. So we are simply concerned with this triangle. And integral just means what? Area. So what's the area of this triangle? It's a right angled triangle. You can use base times height over 2. So the area, base is how many units?
It's 2.
2. Height is 4 units. And the formula is base times height over 2. So the area is 4 square units, whatever the units is here. So it's 4. So that's the dumb way of doing it. It's easy for a straight line, right? Now here's the actual way of doing it. So here, the next step to this, remember the answer is 4. What you do is you find the integral of 2x. What's a function when you take the derivative, you get 2x? What is it?
X squared.
X squared, right? So there you go. So that's your integral. Once you take the integral, this and this disappear. And if you have bounds like we do here, this is called a definite integral, means you can actually find the exact area. Definite just means you know the area to a certain value. So when you have a definite integral, which means these two bounds, what we do is we replace these with a square bracket. We put a 0 here. We put a 2 here. Final step, you plug in these two in there as x. So when you plug 2 in there, you get 2 squared. And if you have other values, you're supposed to subtract them, minus. And then you plug that in there, it's going to be 0 squared. 4 minus 0, the answer is 4. So that's how you'd find the area using the integral method. So you must be wondering, well, why don't we use the dumb way every single time? Why do we have to learn this math, what should I call it? I don't know. There's different types of maths, right? I'll call it an area of math. Why are we learning this? Well, it's because if you have straight lines, it's easy to find an area. But what if I were to do this? Instead of giving you something that you can make a triangle out of, what if I give you a curve like this? Or maybe it even goes like this and then goes like this. How are you going to find this area? Right? There's no way to find this area, at least precisely. You could always draw this on a scale diagram and then count. You know, that's 0.1 of a unit, that's 0.05 of a unit, like that. The big squares are easy, right? You can count all of them. But the tricky thing with curves is like these little chunks. Like, what is this? What is that? Who knows? Like this looks like it's 3/4. Is it? We don't know. So that's the issue with trying to find the area using the normal, the conventional method. When you have a curve, it's next to impossible to be precise when you're doing the area. Okay?
Mm-hmm.
Here, I'll just show you one more example. Maybe you can think of this. So let's just change this. Let's make this, maybe this 3x squared. So there's a function that exists. When you took its derivative, you got 3x squared. What's the main function? So remember, x squared, that means you must have a what? What power? Because you always take one away, right?
X to the power 3.
That's it. That's x to the power 3. Then we have 2, 0. So this becomes 2 cubed minus 0. So the answer is 8. Now that would have been impossible to do if you had when x is 2, y is 8. 1, 2, 3, 4, 5, 6, 7, 8. If you had a plot like this. So this is 3x squared. Now this question is asking you what's the area between the origin 0 and x is 2. Like that's asking you for this area. We know it's 8, but doing this by hand is not really practical, is it? So that's where calculus comes into play. That's where integrals come into play. So that's the whole purpose of this. Cool?
Mm-hmm.
So yeah, the conventional method doesn't work for curves. That's the bottom line. And eventually you will be doing this, and it's not going to look this easy. So right now, for now, we're just finding the derivatives. We're just going down. I just want to show you how to do these quickly because they're not that hard. So part B is a product rule question. So we know for a product rule question, y prime, the derivative is f prime g plus f g prime. So here's what I'm going to do. I have my f, I have my g. I'm going to find f prime. F prime is 24x squared. What's g prime? What's the derivative of this? And remember, you have to use the chain rule.
So do you bring the 5 down first?
Yes, you bring the 5 down. Everything else inside the bracket remains unchanged. And then you multiply it. You take 1 away, then you multiply it by the derivative of the bracket. What is it?
8x plus 2.
8x plus 2. And then you just plug everything into this formula here. It's easy as that. So y prime is 24x squared times the original function as it is, plus the f original as it is, times g prime, which is this thing here. 4x squared plus 2x minus 3 to the 4 times 8x plus 2. So again, this is f prime, this is g, this is f, and this entire thing is g prime. So that's the idea. And eventually you won't have to write this. Like you'll know what the formula is, so you don't even have to write this. So this becomes a 10-second answer eventually, maybe not right now. We're gonna do the same thing for part F. Now part F is a quotient rule problem. So let's see what we can do with that. It's the same concept. The difference in formulas between product rule and quotient rule is this. Product rule is this one that you see, y prime. Quotient rule, you're just going to replace that plus sign in the middle with a minus sign, and then you have to divide this entire thing by the original g squared. So this is your f, this is your g. Okay?
Mm-hmm.
What's f prime?
Negative 12x cubed.
So that's easy. What about g? What's g prime? I'll give you a hint. G, you can look at it as this. This will make things much easier. So that's g. What would be the derivative of that? So So you bring the 1/2 down, right? Just like you did with the 3x4. Bring the 1/2 down. Nothing changes inside the bracket.
Mhm.
You take 1 away from half, so 0.5 minus 1 is negative 0.5 or
Negative.
1/2. Then you multiply it by this. And now you have everything. You just plug it into the formula. So negative 12x cubed times g as it is, so 4x minus 8 square root, minus negative 3x4 times this thing here. You know what I'm doing? This thing all over original. Oh, so this thing squared, the root just kills the square. So the root disappears. And there you go. That's the answer. The root just goes away. Final answer. So even though it looks complicated, it really is whatever, as long as you know how to bring these down. When you can apply this rule, things become much easier. So this y prime would be n times k times x to the power n minus 1. So this is the rule that we've been using. So here you're given two functions. One of them is f, the other one is f prime. Do you know which one is which? It's one of them is the red one of them is the blue one on that plot. Remember, when you take the derivative, you make the function smaller. It's 1 power down, so you decrease its degrees.
So the derivative is the red one?
Yeah, exactly. The derivative is the quadratic, and the other one is x cubed. Notice this symbol, d over dx, means find the derivative. Most of these are pretty simple, honestly. Let me see what the hardest thing here is, if there's anything even that difficult. No, most of them are pretty straightforward. Maybe we will do this. This looks tricky. Let's try this one. Number 11. And you need to get good at sketching these curves. It'll save you so much hassle later, especially if it's a polynomial. So we don't know what this is. It's a quadratic as it opens up, but we have no idea what the x-intercept is or the y-intercept. So we're not too concerned with that. But we can definitely sketch x cubed. X cubed starts in quadrant 3, ends in quadrant 1. Looks like a snake like this. Goes through the origin. I'm just plugging values in. When x is 0, y is 0, so it goes through the origin. At 1, it's 1. At -1, it's -1. At 2, it's 8. So 8 is pretty far away. 1, 2, 3, 4, 5, 6, 7, 8. And -8. Let's just say this is -8. So this is x cubed. For what values of a and b will the parabola this be tangent to the curve at the point 1, 1? So we need a tangent right here, right?
Mm-hmm.
How do we find that slope? You forget about this. Just using this, how can we find that slope? You take the derivative, that'll give you the slope function, and just plug in the x value. That's it. What's y prime? If this is y, what's y prime?
3x squared.
3x squared. So at the x value of 1, what's our slope?
It's 3.
It's 3. So we know the slope there is 3, right? So that means the slope of this function, okay, when we take y prime of this, whatever we get, we know that slope will also be 3. What's y prime?
2x plus a.
2x plus a, and we know the x value, it's 1. So you have 2 plus a, or 2 times 1 plus a equals 3. A is 1, right? A is 1.
Mm-hmm.
You can plug this back in. We know the x and the y values at that point. The y value is 1. The x value is 1. The a value is also 1. 1 plus b. So b is -1. There we go. That's your a and that's your b. Okay? So it looks complicated, but it's not that hard. Just remember, tangent means the rate of change, which is the slope. So just find the derivative function, plug in the slope. Here, maybe let's do 1 or 2 more. This is another, looks super difficult, but it's a 10-second answer. So it says find the equation of the tangent. So this is an irrational function because it's not a polynomial. So sketching this is not going to be that easy. So let's forget about sketching it because we will probably get something like this, like that. Yeah. Sketching this is going to be slightly tricky, but solving this is not that hard. What's y prime?
Negative 6x.
No, think about the bigger function first. So it'll be
You think
5.
the outcome first?
Yeah, it'll be 5 here. 4, and then times what? What's the derivative of the bracket?
Negative 6x
To the,
minus.
remember, you always take 1 away, so it'll be -3 minus 6x squared. So that's our slope function. To find the m value, you just plug 1 in there. When you plug 1 in there, you can ignore the x's because 1 to the power -2 is a 1 to the power of anything is a 1 for the most part. 1 to the power infinity is undefined. And 1 to the power 0, well, that's also a 1. Basically, 1 to the power of anything that's not an infinity is a 1. So this is gone, this is gone, this is gone. So we have 5 times 1 to the power of 4 times -12. So our slope is -60. So the equation of the tangent line is -60x plus mx plus b. How do we find the b value?
You plug in points
Yeah,
for y and x.
you already have the x and the y value right here. So 1 equals -60 plus b, b 61, 1 and done. All right, let's move on from this. We will do some prerequisite problems. And again, most of these are super simple. I'm going to ignore the linear ones. Root x, you know how to sketch linear. You can either plug in points or you turn this into the slope intercept form. By that I mean this. You just rearrange it and you can draw a straight line. We're beyond straight lines now, so I'm going to ignore straight lines. Square root function, root x, looks like this. Starts at the origin, and you can always plug values in. A table of values would be 0, 0, when x is 1, y is 1, when x is 4, y is 2, like that. So that's a square root function. D says x minus 2. Now be careful. X lies. Keep that in mind. X lies. The -2, would you expect this to go up, down, left, right? Only one of them is right.
It's going left.
It is actually going right. So you'd expect it to go left because of the minus sign, but turns out it's going right. So it's the same curve as we have here, except the origin was at 0, 0. Now it's 2 units to the right, so it's at 2, 0. Like that, and it's the same curve. It's just a horizontal displacement, shift, translation, any of those words. It just moved 2 units to the right. E is a quadratic opening upwards, y-intercept of -4, like that. F is a quadratic negative, so it opens down, y-intercept of 9, like that. You can find the x-intercepts here as well. This will be 3, -3. By setting this to 0, you'll get root 9, 3, -3. Same thing here. If you set this to 0, root 4 is 2 and -2. So there you go. Those are the plots. Not that tricky, right? It's just basic curve sketching. We will do this problem. It says solve this equation. How do we go about solving this equation? So it's a polynomial. By that, it has power 4. Everything is on the same side, so that's good. How do we solve this equation? So let's think. There is a way of doing this. There's 2 ways that I can think of right now. You by hand. Obviously, you can always plot it on Desmos or whatever. But by hand, I see 2 ways of doing this. One of them I think is better than the other. Let me show you the other way of doing it because so there's a dumb way and there's an efficient way. To use the efficient method, you have to be able to see it. And if you haven't seen it before, you probably won't see it. So let's do it the conventional way, which is this. To solve a polynomial with power greater than 2. With n is just the power greater than 2, not equal to 2. Strictly greater than. So I'm talking 2, 3, 4, 5, 6, yada yada from there. You have to, or one method, use the remainder theorem and factor theorem, which says this. Your function is f of x, whatever this is. So for us, this entire thing on the left side is f of x. You want to plug values in there as x. That would make this equation true. That would make this equation equal to 0. And the values of these numbers that you put in, okay, maybe I shouldn't call it f of x. I'm going to call it f of a. These a values that you put in, that you check for, that you plug in and check, there will always be factors of the y-intercept, which is this constant here. Any polynomial, the number that doesn't have a letter attached is the y-intercept. What are factors of 9? Give me some factors of 9.
3.
3 is good, yeah. Anything else? There's actually 6. So 3 is 1, plus minus 3. That's another. Both positive and negative 3 can go into 9. The other one is the number itself, 9. The other one is 1.
1.
1 is always going to be one of the factors when you're doing these problems. So this one is easy. They kind of, led us to this. You always start by plugging the smallest number. So let's plug positive 1. What is f of 1 here? Is it 0? When you plug t as 1, what do you get? When you plug t as 1, you get 4 minus 13 plus 9 is equals 0. Is that true? Yes, it is, right? -9. If you want the steps,
Mm-hmm.
you have -9 plus 9 equals 0. So that statement is true, which means that t minus 1, this number, and our variable of interest is t minus 1 is a factor of f of x. Then once you get this number, you're going to do synthetic division with it. Now the way synthetic division works is that this number that you had comes here as it is. You can also do long division like this, but long division I think is a little bit dumb. There's more room for error. You can't always use synthetic, but if you can, synthetic is like at least twice as fast. So I'm gonna stick with synthetic, but maybe I'll show you how to do it both ways. Yeah, why not? Let's show you. It'll be a good recap. So this is called polynomial long division. You have to use this method if you are using the remainder factor theorem. So notice t cubed is missing. You have to manually add a t cubed. It has to be in descending orders. So yeah, I know we don't have t cubed. So what I'm going to do is I'm going to write this as plus 0 t cubed. You'll see why. Otherwise, the letters, they don't match up. And then everything else we have t squared. T is also missing. Plus 9. The powers, right? Look at this, 4, 3, 2, 1, 0. This has to be the case. Doesn't matter if you're doing polynomial long division or synthetic division. The powers always has to be in descending orders. If anything is missing, add that as a 0. For synthetic division, what we do is we only care about the coefficients. It's the same thing, except we don't care about the t's. We're strictly concerned with the coefficients, like that. Now you want to ask yourself, how many times does t go into 4t power 4? In other words, t times something is 4t4. What is this?
4t cubed.
Yeah. So that's going to go up here. 4t cubed. So when you multiply one letter by 4t cubed, you also have to multiply the other term, which is -1. So look at this. T times 4t cubed is 4t4. -1 times 4t cubed is -4t cubed minus 4t cubed minus 4t cubed, nada. 0 to cubed minus becomes a plus 4t cubed becomes 4t cubed. And when you cancel out something, you're allowed to bring another term down. Only when you cancel something. Now you ask yourself again, how many times does t go into 4t cubed? 4t squared, yeah?
Mm-hmm.
So t times 4t squared is 4t cubed. -1 times 4t squared is -4t cubed. Subtract. This minus this is nothing. -13 minus becomes -13 plus 4 becomes -9t cubed. Then you bring this down. How many times does t go into -9t cubed?
-9t.
-9t. So that goes up. The quotient always goes up. And down here, t times -9t is -9t squared. -1 times 9t is plus 9t. So when you subtract them, this becomes a plus. This cancels out. 0 minus 9 is -9t. If we bring the final letter down, plus 9. T goes into -9t -9 times. So this becomes -9t, becomes +9. When you subtract them, you get a 0. So there you go. That's how you do polynomial long division. It's a little bit easier when you do synthetic, because when you do synthetic, this number always drops. Step number 1, the first coefficient, the biggest coefficient of your degree term, drops as it is. Now you have to multiply it diagonally. 1 times 4 is a 4. Do we add or subtract in synthetic division? In long division, we subtract. In synthetic division, we would add. 0 plus 4 is a 4. And then again, you do 1 times 4 goes here. What's 1 times 4?
4.
What is negative 13 plus 4? Negative 9.
Negative 9.
Now 1 times negative 9 would go here. Negative 9. 0 plus negative 9 is negative 9. Finally, 1 times negative 9 is negative 9. 9 plus negative 9 is a 0. And you see these are the coefficients. So we started up with T4. That means when you do synthetic division, this one will always be 1 power less. So that is 4t cubed. The sign here is plus. 4t squared. The sign here is minus. T. The sign here is minus sign. And now check this out. This and this exact same thing. But obviously, synthetic is quicker, right? But synthetic you can only use when your divisor, the thing you're dividing by, is a linear function like this, t squared, t minus 1. Because that was t, we could use synthetic division. If this was t squared, then synthetic division fails. You cannot use synthetic division, okay?
Mm-hmm.
To solve this problem, now what you do is you turn this into another f of x, and then you check for factors of 9, which we know what they are. And then you plug one of these in, see which one gives you a 0. And then you do synthetic division one more time. The quotient, finally, after you do a synthetic division a second time, your quotient would be a quadratic. So at that point, you can either man this or use the quadratic formula to solve it for x. So that's how you do this problem the conventional way, okay?
Mm-hmm.
Kind of dumb because there's a lot of room for error with this. So I'm gonna try another method. This one works if you see it. So here's the other method. We're gonna let t squared be x. We're gonna do a substitution. Why am I doing this? It's because our function will end up looking like this. If t squared is x, what's t4 in terms of x? What did we do to t squared to get t4?
You multiply by t squared.
We multiplied it by t squared, but we don't want to think of it in terms of multiplication. We want to think of it in terms of power because we can't multiply by t squared. That would mess things up. We squared it, okay?
Mm-hmm.
T squared, we squared it to get t4. That means t4 in terms of x, the equivalent is x squared. We squared one side, we must square the other as well, like that. Why am I doing it this way? Because I can man this. Check this out. So the t4 becomes 4x squared. T squared becomes an x plus 9 equals 0. Now we have a grade 10 quadratic. We don't have to worry about synthetic division or any of that shenanigans. This one is manable. I think it is. What does it multiply to? What does it add up to? You remember, man? It adds up to the middle number, negative 13. It multiplies to the product of these two, A and C, 36. Always, it adds up to the middle, the coefficient of x, okay, keep this in mind. Always adds up to coefficient of x power 1, so negative 13. And the multiplication is this coefficient, the first coefficient, times the last coefficient. So what are our numbers? Multiplies to 36, adds to negative 13. Does it exist? And it does exist. The numbers are on the screen, actually. The two numbers that you're looking for are already on the screen.
Minus 4.
And now it has to add up to negative 9.
instead of negative and negative
Yeah.
9 and negative 4.
Yeah, -9 and -4. So when you're doing man, you're gonna turn the middle into these two numbers. The b value, -13x, becomes -4x minus 9x plus 9, like that. Now you want to factor by grouping. From the first two terms, you can pull out a 4x. What are you left with if you pull out a 4x?
X minus 1.
If you pull out -9, what are you left with in the other bracket?
X minus 1.
Now you're going to pull out the x minus 1, and whatever leftovers, they go in the other bracket. So 4x minus 9 equals 0. So that means our answers are x equals 1, sorry, and x equals 9/4. But the question is not asking us for x, right? It's asking us for t. So now we're going to do a replacement. X is t squared. So replace x with t squared equals 1. Replace x with t squared equals 9/4. If t squared is 1, what's t?
It's 1.
There's two answers. One is one of them. There's another one.
Negative 1.
Yeah, so it's plus minus 1. T squared is 9/4. What's t?
3/2.
Yeah, plus minus 3/2. Here's something you want to keep in mind. So that's the answer to this question. This is way easier than doing it the synthetic in whatever way. This is going to sound a little bit weird, but square root of 4 is 2. But if you have this, if you have an equation, then x is the square root of plus minus 4 plus minus 2. So make this distinction. When you're solving for an unknown, it's going to be the plus minus. But if someone asks you what's the square root of 36, well, it's 6, okay? Yeah, so that question was interesting for sure. Now, the method that we used here would not apply here. Here I could see that t squared t4, I can make this x, this would automatically become x squared. I can man it. But now that fails in h because I can't write t squared in terms of t3. I could do 1.5, but then I can't man x to the power of 1.5. So our substitution is gonna fail here. Let me just show you what I mean. Actually, yeah, it's gonna fail anyways because if t squared is x, look at how weird this becomes. This becomes x to the power of 1.5 plus 12x minus root of x minus 3 equals 0. So I've just made this way more complicated using a substitution. So it's not always going to work. So now how do we do this question then? Well, we can always do it the conventional way of trying to figure out synthetic long division, what adds up to this and that. But I'm a big fan of if you see it, your life becomes so much easier. Look at this. The coefficient here is 4. The coefficient here is 12. So I can see that this is times 3. What's the coefficient here? What's the coefficient of -1? Oh, it's -1. I gave it away. Yeah, so coefficient of t is -1. This is -1 times 3, right? You see that pattern? If you have this, things become even more easier. You don't have to worry about quadratic either. You factor by grouping. Try this. Always try this first. By grouping, I mean 2 terms at a time. Whenever I'm saying grouping, I'm saying 2 terms at a time. So we're going to be looking at these two, and then we're going to be looking at these two. So 4t cubed plus 12t squared. Is there anything that we can pull out?
3t squared.
3t squared? Not 3, 4t squared. what are you left with? There'd be two terms in this bracket.
T plus 3.
Yes. What can you pull out from the next two terms?
-1.
-1. What are you left in a bracket?
T plus 3.
Yes. So now you have t plus 3, 4t squared minus 1. So the answer from here is -3. The answer from here is, well, 4t squared is 1. T squared is a quarter. T is, again, remember, it's 1/2, but it's plus minus 1/2. So this thing has three solutions, okay? And look at how easy this was. If you see it, it's way easier. And there's gonna be someone, if this comes up on a test, there's gonna be definitely someone trying to do synthetic and that and that. That works. It's not that it doesn't work. It's just that this is way quicker. So you'll be wasting 10 minutes the other way. And time is precious, especially in a exam setting. All right, let's do some of these. It says solve an inequality. Now notice the sign in the middle is no longer an equals to. If you have greater than, less than, greater than, equal to, less than, equal to, these are called inequalities. Again, what's happening here is this. You have your curve 3x minus 2. So the y-intercept is -2. What's a point on this curve? Or you can also think of it this way. Slope is 3, +3, so you're gonna go up 3 units, move away 1 unit, right? Like that. So your curve will look like this. And again, it's a straight line. Extends forever in both directions. There we go. Now it says greater than 7. What does that mean? So now let's find the y value of 7. 1, 2, 3, 4, 5, 6, 7. The y value of 7 is right there. So I'm going to denote this by using a dotted line. I can just draw it, right? So this is y equals 7. That point is 1, 2, 3. That point right there is 3, 7. So what this question is asking you is for which x values, that's what it says. For which x values, it's going to be a range of x values, is the blue line, we want the blue line, 3x minus 2, to be greater means over or on top of the red line. What's the answer to this question?
It's 3.
It's 3x less than 3 or greater than 3 or equal to 3?
Greater than 3.
Yes, so the answer to this is x is greater than 3. Now you don't have to do all this sketching shenanigans if you don't want to. You can do this algebraically. So let's bring this down. 3x minus 2 is greater than 7. Yeah, I know it's not an equals to, but we're going to treat it like an equals to sign. Add 2 on both sides. Divide by 3 on both sides. There we go. You can get the answer in 5 seconds. So that's what we're doing, okay? This way, you have to be careful, okay? You have to be, I'm just going to put this as note. If ever you're multiplying or dividing by a negative number, what happens to the inequality?
It flips.
It flips. So if you're doing it this way, the inequality has to flip. This is good for understanding the problem, right? It kind of shows you what the question is asking you, but this is definitely the way to do it. Now this next question is even weirder. It's the same kind of idea. This one, I think you have to be able to sketch this. If you can't sketch this, then it's hard. This one I would recommend sketching because it's a degree 2 polynomial. Anytime you have more than one x-intercepts, then things get weird. You don't know if you're looking up here or down here. That's the biggest issue. You don't know where the curve is. So if you can, just sketch it. This one's very simple to sketch. There are two x-intercepts. What are they? It's a quadratic. What are the two x-intercepts? Forget about this. Completely forget about this. This is your function. It's in factored form. It's a quadratic. It has two x-intercepts. What are they?
One of them is 3.
One of them is 3. What's the other one? Comes from this. Comes from the x that's on the outside. It's a 0. Okay?
Mm-hmm.
Because what we do is we set them equal to 0 individually. So you get x equals 0 and x minus 3 equals 0. X equals 3, x equals 0. So the two x-intercepts are 0 and 3. If the x-intercept is 0, the y-intercept is automatically 0. So you don't have to worry about that. Is it opening up or down? It's opening up. Because both of the x's are positive. And it's going to have a vertex at 1.5. Yeah, it's not super important, but it'll have a vertex right here at 1.5 and negative 2.25. We don't need the vertex to solve this problem. We just need to see the general shape. But you know what? It's going to have a vertex somewhere underneath the x-axis. So here's your curve. Now, what is this question asking you? This question is the same. For which x values is the green curve over the x-axis? X greater than 0, 0 means the x-axis. So for which x value is a green curve over the x-axis? It's going to be a range of values again. So we're looking at this section. That's above the x-axis. And we are looking at this section as well. It's above the x-axis. And we know the x value. So what's the answer to this? There's two answers, one on the left and one on the right.
When x is less than 0.
Yep. What about the other side?
When it's greater than 3.
Yep. Not equal to 3. This equal to would only be equal to if this was equal to. If there's no equal to, don't put an equal to here. So those are the two answers. When x is less than 0 and when x is greater than 3. Okay? That's it.
Mm-hmm.
This next one is very similar. You have to factor this first though. So let me pull out a negative x. I'll be left with x minus 4 equals 0. Where are the x-intercepts? One of them is at 4. Where's the other one? The same idea as the one before. It's at
0.
0. Opening up or down?
Down or
Down.
up.
So it's going to look like this. It's opening down. Now it's going to have a vertex somewhere. The x value of the vertex is going to be between 4 and 0. It's going to be 2. The y value will be negative 2 times negative 2 positive 4. So that's our vertex. Now this question is asking you, when is the green curve above the x-axis? Same question. What's the answer?
When x is greater than 0.
So it's right here. How would you describe this region? When x is between two numbers.
Between 0 and 4.
That's the answer to this question. So sometimes sketching is actually easier. Other times, not so much. But it's good to, yeah, you have to be pretty good at both of them. And I think you are, or eventually you will be. All right, let's call it there for today.
Okay, thank you.
See ya.